To general physics. In this short video, I'm just going to go over what we're going to be studying in physics. So what is physics? Physics is the most basic science. Basically, we want to know how everything works. In this class, we're going to be studying part of physics. We're going to be studying mechanics, mostly about how things move, electricity and magnetism, and waves. So these four pictures seem to be very different things. We have a galaxy, bike riders, little electrical circuits, and waves. But they're all physics. This has to do with motion or mechanics, the writing. The circuits are electricity. We got waves over here. And this would be mechanics as well, the galaxy, because it's spinning. So our first part of mechanics is going to be kinematics. How things move is called kinematics. We're going to study how things move. Do they speed up, slow down? How fast will they be going? What is their acceleration? So anything that's moving. Could be race cars, roller coasters, sprinters. So here are some pictures. So we might study the speed of a race car, the acceleration of a cheetah, or of just a kid on a bike. Dynamics is also about motion, but it's why they move. In order to change the speed, we have to put a force on it. So we're studying the forces in dynamics. So how does the force affect the motion? How does the mass affect its motion? It's going to be similar examples because it's still motion. So here's a picture of a plane, and it's got some forces. It's got a thrust force, a drag force acting on it. And what's going to happen if the thrust force is increased or if the drag force is increased? Then we're going to move on to momentum. So that's concerned with collisions, two things coming together. So we'll study cars crashing, or explosions, two things flying apart. And explosions are like collisions in reverse, so it's the same process, the same type of problem. So some examples, we might talk about running backs crashing into linemen, okay? Or we might talk about bullets being fired from a gun. So here's an explosion problem, and here's a collision problem. Another way of looking at motion is looking at potential and kinetic energy. When something is high, it has a lot of potential energy, and as it falls, it loses the potential, which turns into kinetic. So a skier on a hill, a roller coaster car, or a skydiver. So these two problems, the kid on the little roller coaster or this pendulum, we're going to be studying potential and kinetic energy. Then we're going to move on to electricity and magnetism. We're going to start with static electricity. So how do charges build up and then suddenly jump? And there are a lot of everyday examples. When you get a shock after rubbing your feet on a carpet, it's actually the same process as lightning, just on a much smaller scale. And one thing we're going to talk about is why is a car a safe place in a lightning storm? And it's not the tires. So here's some pictures of static electricity. And again, the same thing that makes this little kid's hair stand up causes the lightning. Okay, lightning is just a bigger scale. And it also causes balloons to stick to this guy's head. Current electricity is not like static electricity where the charges build up and then jump. They have to flow continuously. And everything that is powered by electricity uses current electricity. So there's a lot of uses to this. So here are some pictures of things we'll be looking at in current electricity. The last part of the electricity and magnetism unit is going to be magnetism. There are things that are permanent magnets, and what makes them a permanent magnet, and how do they behave? But then there are electromagnets. If we get current going through a wire, it actually becomes magnetic. And they're used in speakers and televisions. And one thing we're probably going to do is build our own speakers out of paper cups. And they will actually work when we hook them up to a radio. And how are magnets used to create electricity? That's how microphones work and power stations work. So here are some magnetism examples. We've got an electromagnet over here, and it's strong enough to pick up all of that metal. But as soon as you turn off the current, it drops the metal. The Earth is a big, giant permanent magnet. And as we said, speakers use magnets. And our last unit is going to be on waves. In waves, we're going to study many everyday things: sound, light, water waves, radio waves. We'll answer questions like, why is the sky blue? Why do race cars seem to change pitch as they zoom by? They go, meow. And how does police radar determine your car's speed? And here are some pictures dealing with things that we're going to study in the waves unit. Now, these are just some examples of the topics we will be studying. We're not going to study everything that's in physics. Physics really want to know how everything works. It is the most fundamental science. All sciences boil down to physics if you look deeply enough. If you think about biology, the way a cat moves, its brain sends electrical impulses. Okay, so that's electricity. That's a physics topic. Through its nerves to its muscles. And then the muscles put a force on its skeleton, and that causes motion. Chemistry, molecules are formed by the electrical attraction between atoms. So if you study biology or chemistry deeply enough, you eventually start having to learn some physics.